So let's just call the smooth guy A, because that's what we've been doing all along. And he can either choose to cooperate or he can choose to defect. Now, by the way, I'm saying cooperate and defect here because they're terms of art, not because these are the words I would have chosen. Okay? B can do the same thing. B can choose to cooperate or B can choose to defect. Now, I've set up the game in a particular way here. The cops have set up the game in a particular way here. If B defects but A cooperates, then B gets to walk and A has to pay the price, 9 months in jail. So I'm going to put into this cell -9, 0. So this means this is the value of this set of strategies for A, and this is the value for B. So the first number in the pair is what A gets, and the second number is what B gets. Okay?
Got it.
You with me? Okay.
Yep.
Now notice we have to do this now because it's no longer zero sum. It's not going to always add up to a constant.
Well, it is. So far it's a constant. It's -9.
That's right. Oh, and in fact, it looks this way as well because I have a symmetric deal here. So if A defects and B cooperates, A gets to walk and B goes to jail for 9 months. Okay?
Yep.
So right now, you're right. It's looking like a zero-sum game, but it isn't. Because what happens if both A and B drop a dime on each other? Well, they both confessed. So it's a little good. It's a little bit better than having one of them, only one of them confess. The deal that the DA is willing to give them is that both of them will spend 6 months in jail. Now, these are just the numbers that are a part of the game. I'm not computing this from anywhere. This is just the way the cops have set this up. And now what's an interesting question here is what happens if both A and B keep their mouth shut? They both choose to cooperate. It turns out that it's not a perfect world because they were caught with a bunch of guns they didn't have permits for. So if neither one of them admits to robbing the bank, they're still going to do a little bit of time. But in this case, it's a small weapons charge, and so each only spends a month in jail.
I see. So now it's definitely not zero sum because we have a -2 there, -12 there, a -9, and a -9.
Right.
Okay.
Okay, so you got the game? You understand it?
Yeah, I think so.
It's very simple. Now, just looking at this, what's the best possible outcome for the two of them?
So if they cooperate with each other, then there's 1 month later, they're back on the streets, back to their criminal activities.
Or they're reformed. You never know.
Sure. Back to their choice of whether to have criminal activities. The mutual defection one, where they both defect, it's either 12 months or 6 months, depending on how you think about it, but they don't do nearly as well. And then the defect and cooperate, it seems like there's a lot of incarceration that will happen. So it feels like the best for the two of them is the mutual cooperate.
Yeah, and that makes sense. This is sort of what you want to happen. Both of them keep their mouth shut. They do a little bit of time, but on average, they do pretty well, right?
Yep.
So my question to you is that going to happen?
Sure. Why wouldn't it happen?
Well, you tell me. If I know that you're going to cooperate, let's say that I'm A, okay, and you're B, and I know that you're going to cooperate. What should I do?
You should cooperate.
Should I? You've chosen this column, right?
I see. Well, if you think of it that way, that it's not a joint choice, but it's actually an individual choosing, then you're better off defecting because then you get off scot-free.
Yep.
But I go to jail for 9 months. I could have a whole baby in that time.
It usually takes closer to 10, but sure. But you go to jail for 9 months. I don't.
So if you are just that cold, I guess because you're a criminal.
It doesn't matter. Remember, the matrix is everything. The value of doing this to me is 0 versus -1.
All right. That's cold, man.
I agree, but it's what the numbers tell you. What if it wasn't criminal? What if it was just, the amount of money that I was going to win in a mini poker game?
Yeah, but it's a different kind of mini poker game because it's like you beat me, but by beating me that way, you nearly kill me.
So? Are you saying
What do you mean,
Are you saying you always let me win whenever we play poker?
No.
Okay, then. Because you're cold. Is that what you're saying?
No.
Exactly.
Wait, what?
Right. So the point, Michael, is that if I know you're going to cooperate, you're going to choose this column, then I should defect.
Okay. All right. So fine. So now I'm going to jail for 9 months.
If you choose to cooperate.
Aha. If is good. So what you're saying is I could drop a dime on you.
You could. So you could choose to defect. And if I knew you were going to choose to defect, what would I do?
Well, you already showed your colors, man. You're defecting. So I'm just switching. I'm just saving myself 3 months by ratting you out.
Yeah. So we would end up here. By the way, you know that this game is symmetric, right?
No, you defected first.
No, here's the thing. Since the only thing I care about is maximizing my own reward, my own value, I'm going to do the thing that makes sense for me to do in this case, which is if you cooperate, defect. If you defect, defect. But you would do the same thing because your whole goal here is to maximize your value.
Yeah, well, you don't know me like that.
Yes, I do, because it's everything that's here in the matrix. This is the wonderful thing about game theory. All the stuff that you're concerned about, it's all inside the matrix. Remember, the rules of the game don't matter. There's no prisoners here. There are no criminals. There's just I get $1, I lose $1, or I lose $0. I lose $9 or I lose $6. Or, for that matter, cents. I lose 1 penny or I lose no pennies. I lose 9 pennies or I lose 6 pennies. It doesn't matter. This is the value of these particular strategies, and I'm going to want to defect if you cooperate. You'll notice if you defect, I'm also going to want to defect. In fact, if you look closely at this matrix, you should notice something, Michael. From A's point of view, when does it make sense for me to cooperate versus defect?
You mean if you have some kind of probabilistic policy over cooperate and defect?
No, not even that. Just in general, is there ever a time as A that I would rather cooperate than defect or vice versa?
Oh, I see. So if I know you're going to cooperate, I should defect to save myself a month. But if I know you're going to defect, I should defect to save myself 3 months. Either way, I'm coming out ahead.
Right. So in fact, let's take a look at this.